The rational zeros theorem is a way to figure out what might be zeros, okay? It looks really complicated. It says if P over Q is a rational number written in lowest terms and P over Q is a zero of F, a polynomial function with integer coefficients, then P is a factor of the constant term and Q is a factor of the leading coefficient. That's really tough to understand without a formula. It says P is a factor of the constant term. So they're talking about like this last thing is P, the constant term, and Q is a factor of the leading coefficient. So Q is like that 8 right there, all right? So they're talking about the last term and the first term is what the numbers are that you would look at, okay? But I've got a caution. This only gives possible zeros. So if you look at a polynomial like in example 3a, with x to the fourth, you would expect there to be 4 zeros. X to the fourth, you would expect it to see 4 zeros, all right? This rational zeros theorem is probably going to give you a list of more than 4. It's just giving you some ideas to try. These things might work, okay? 4 of these are going to work, but I might give you more than that, okay? So this is not very fun, but it's not very hard, okay? So here's what you have to do. Look at your P number and your Q number and determine all the factors of those. So for this P number, factors of 4 are 1 and 4 and, 2 times 2, so just 2. So 1, 2, and 4. 1, 2, and 4. And factors of 8, you've got 1 and 8 or 2 and 4. Okay, so basically what you have to do, according to the rational zeros theorem, is look at P over Q. So if I'm going to do P over Q, what you're going to do is you're going to take each of those numbers on the right divided by each of those numbers on the left. Now, it might have been easier if I had used 2 different colors. So let's do this. Say this is 1, 4, and 2. Okay? Each of those blue numbers divided by each of those green numbers. So let's do this. Let's do 1 over 1 and 1 over 2 and 1 over 4 and 1 over 8. So I took the first blue number and divided by each of those green numbers. Now go to the next blue number. You've got 2 over 1 and 2 over 2 and 2 over 4 and 2 over 8. And keep going. You've got 4 over 1 and 4 over 2 and 4 over 4 and 4 over 8. Each of the blue numbers, each of the P numbers divided by each of the Q numbers. Now, you might notice if you reduce those fractions, some of them are going to be the same. Okay, great, cool. Also, what you're going to have to do is say that positives and negatives work. So what I'm going to do for my answers here, my possible rational zeros, I'm going to reduce each of these fractions. So the first one, 1 over 1 is 1. So I'm going to say plus or minus 1 right there. And then you've got plus or minus 1/2 and plus or minus 1/4 and plus or minus 1/8. Keep going. I've got plus or minus 2. And then the next one, notice it reduces to 1, and I've already got 1. And the next one reduces to 1/2, and I've already got that one. And then there's 1/4, and I've already got that one. And 4 over 1, okay, 4 over 1's new, so I've got plus or minus 4. But 4 over 2 reduces to 2, I've already got. 4 over 4 reduces to 1, which I've already got. 4 over 8 reduces to 1/2, which I've already got. So this is my list of possible rational zeros, okay? I suppose there could be some irrational zeros, but anyway, if we had 4 zeros, if any of them are rational, then it's going to come out of that list, okay? Now, will all of those numbers work? Absolutely not. At most, 4 of them could work. Less than that if some of the numbers are irrationals. Some of the zeros are irrationals, okay? So then part 3b says I want to factor that thing, okay? Now, this is very similar to problem, what was it? 2. Problem 2 says factor the polynomial, but problem 2 was much, much easier because they gave me the first number to try. They said 5 is a 0, try that first. This one, we don't know. We don't know what's going to work, and so here's what you're going to hate. What we're going to have to do is just start trying those numbers until we find one that works, okay? We'll break down the problem, and we'll try another one, and we'll try another one, and we'll try another one, okay? We'll keep trying numbers until we find them. If we can break a problem down into something that we can factor, we'll factor it, because I'd rather factor personally than do this process, okay? Doing the process is fine as long as it works and you get a 0, but if you don't get a 0 and it doesn't work, then you got to try something else, and it's kind of a pain. So let's just go through our list. The first number in our list is 1. Let's see if 1 is a 0. You've got 8x to the 4th minus 26 x to the 3rd minus 27 x squared plus 11 plus 4. Okay? So add down is 8, multiply is 8. Add down is negative 18, multiply diagonal is negative 18. Add down is negative 45, multiply negative 45. Add down 11 minus 45, that's negative 34, and multiply is negative 34. Add down is negative 30, okay? So you see how that number is not 0? That tells me that 1 is not a 0, and that doesn't work. So essentially, I just wasted my time. I've got to try a new number. So let's try negative 1. 8, negative 26, negative 27, 11, and 4. Hopefully this one will work. Add down, you get 8, multiply, that's negative 8. Add down, negative 34, multiply, positive 34. Add down is 7, multiply is negative 7. Add down is 4, multiply is negative 4, add down is 0. Aha! This one works, okay? That works, so that means that this, go ahead and circle it, is a 0, okay? If that's a 0, that means that x plus 1 must have been one of my factors, okay? So I know x plus 1 is one of my factors. Maybe we should write it down right here. X plus 1. Because we're trying to factor the thing. We got one of the factors as x plus 1, okay? Now, here's what you want to do. We've just reduced the problem down into 8x, oops, where am I at here? 8x to the 3rd minus 34x squared plus 7x plus 4. We want to use the reduced problem. We don't want to use the original problem because we've reduced it down. If we can factor that reduced problem, then we do that. Unfortunately, I don't know how to factor that, okay? And so what we have to do is we have to try another number. Try something else until you find something that works, okay? So really, I didn't really care to write that down, but I do want to use these numbers right here. I'm using the reduced numbers, and negative 1 might actually work again, but I'm going to move on. Let's try number 2. Let's try 2. I could use 1/2. I could try negative 1/2. I could try anything in my list that I want. The only thing I wouldn't try is something that I already know isn't going to work. So I've got these numbers. Add down is 8, multiply 16. Add down negative 18, multiply negative 36. Add down negative 29, multiply negative 58. I don't even really care what this is because I can tell it's not 0. I can tell it's not going to work. Really, as soon as you can tell that it's not going to work, you might as well move on to the next number. Okay, so let's try negative 2. I'm using my same reduced numbers, 8, negative 34, 7, and 4. Add down 8, multiply negative 16. Add down negative 50, multiply is 100. Add down 107, multiply negative 214. Yeah, that's not going to work either. It doesn't work. Okay, so try something else. You can try one of the fractions if you want to. I usually stay away from the fractions, but sometimes the fractions are the ones that work, so you can use them too. 8, negative 34, 7, and 4. Add down is 8, multiply is 32. Add down negative 2, multiply negative 8. Add down negative 1, multiply negative 4, add down 0. Hey, look at there. Okay, that works. So circle the 4. I know that's one of my zeros, and I know x minus 4 is one of my factors. Remember, that's the point. I'm trying to factor this thing. But what I've also done is I've reduced the problem down again. Okay, so remember it was 8x to the third here, but now it's 8x squared because I've reduced it again, minus 2x minus 1. And so again, if you can factor the problem, that's probably what you want to do, because that's going to be easy. I mean, you can continue trying these numbers, but I'd rather factor it. I think it's a faster process for me anyway. If I was going to factor this, I would know it's either 8x and x or 4x and 2x. The number at the end is negative 1, so there's only, I mean, it has to be 1 and 1. Something's going to be a 1, and something's going to be a negative 1, so I know there's going to be a negative in there. I'm strongly suspecting that 8 isn't going to fly. I think it's going to be the 4 and the 2. So if you think about it, you'd have to multiply one of them by 4 and one of them by 2. And in order to produce this negative 2, okay, we've got a negative, so we need a negative in this problem. I can do what? 4 times negative 1. That's negative 4, and then plus this 2. That would give me my negative 2. Okay, so that's kind of my factoring process. That's what I'm doing. I know that there's a negative 1 and a 1. And specifically, I know the negative 1 has to go over here because that's the position that's going to get multiplied by the 4. There's a plus 1 there, and so I've got that thing factored. Okay? I've got that thing factored, but wait a minute. Remember what we had. We found this factor, x plus 1. And then we found this factor, x minus 4. And then we had these two factors over here, 4x plus 1 and 2x minus 1. Now, at this point, if you're saying to yourself, but I don't know how to factor, I can't do that, then you can still get the answer. But the problem is you're going to have to do more of this process. Okay? You're going to have to keep trying those numbers. Keep trying these numbers until you find all of them that work. And so notice, if you notice, this 0 is negative 1 and this 0 is positive 4. But this 0 was negative 1/4 and this 0 is positive 1/2. So you would have had to have tried those fractions in order to find the ones that work. Not impossible. I just personally think that factoring is easier.